Now, our lesson yesterday was talking about isosceles and equilateral triangles. We said that this type of triangle, we called it an isosceles because it has a vertex with two vertices. We have two sides. These two sides are congruent and we name it with leg. And we said that the sides that connect between these two legs are base, we name it the base. And the angles on it, we name it with the base angles. And we state also that one of the theorem for the isosceles triangle that says if AC is congruent with BC, if these two sides are congruent, so now here if you have this triangle and this one and this one are congruent, you have to look at this side. For this side here, the red one, this is its opposite angle. And for this side, which is the yellow one, this is its opposite angle. Because of that, if the red and the yellow one are congruent, so the angles in the red and the yellow are congruent too. This is my first theorem. And we prove this theorem. And then we talk about another one. And the another one here, he told me now that if you have now this triangle here, okay? Now, for this triangle, as you see now, if the red angle is congruent to a side and the blue angle is congruent to the another side, and these two red and yellow angles are congruent, so I can conclude that the two sides, the yellow and red, are congruent too. We said it is a converse of the first theorem. And we prove it also. We solved this one and we stopped here. In this one here now, he asked me that if you have this triangle, as you see in this picture here, he asked me now, is the angle of WVS is congruent with an angle S? Here you have this big triangle. Here it is R, T, and S. And there's another line segment here from V. Cut this one with W and cut this one with U. Its name in the intersecting is F, SV. And here now we have an angle. This side and this side are congruent. Now he asked me a question. Is the angle WVS, I mean this angle now, is congruent with this angle?
Yes, teacher.
Can I answer?
Yes, please.
It's congruent.
Yes, it's congruent.
Why, Jenna, it's congruent?
Because V.
It is, yes, thank you. But why?
It's given.
Can I please say?
Yes, Jenna, can you tell us why or let another girl?
Yes, Miss. How? Can I try, teacher?
Yes, Basma.
Because the two sides are congruent.
Thank you. Since now these two sides are congruent, so their opposite angles are congruent, according to our theorem. We say that if we have two sides are congruent, so since this side are congruent with this side, so this angle are congruent with another angle. So yes, since WV is congruent with WS, so angle WVS is congruent with an angle S, according to the theorem. Which theorem number? Let's see, go back here.
4.
Let's see, which one told me that? Now, in 4.3, he told me if two sides are congruent, so the angles are congruent. So, which is 4.3. So, because of the theorem, because of the theorem, 4.3. Now, the second one is TR. Where's TR? TR. This one.
Miss,
Yes.
here they are saying the theorem 4.3 is saying that two sides of the triangle are congruent. Then the angles will be the two angles.
Yes, will be congruent.
Okay.
The opposite. Now look at this side here. And this side, the yellow one. Its angles, or its opposite angle, are this one. Is this one. And this side, its opposite angle is this one. So this angle and this angle will be congruent. Why? Because its opposite sides are congruent.
Okay.
So this is because of theorem 4.3. Now look at the second one here. In the second one, he asked me now, is TR? That's me. TR, where's TR? This one. Is TR are congruent with TS? I'm asking you now about the sides. Are the sides are congruent? If I want to examine that, if these two sides are congruent, I have to check what? What I have to check if I want to see that these two sides are the angles.
Angle.
So let's see now the angles. Look at this picture here, the up one.
No, teacher. I cannot conclude that. Oh, Miss RUV. No, wait to check.
Teacher, can I answer?
Yes, please.
They are congruent because we already found that R and S are congruent to each other. Teacher, I'm going to check something quickly.
Teacher, I say that they are not congruent because there's not enough information.
Okay.
Me too, I say there's not enough information.
Me too.
Teacher, can I answer quickly?
Yes, please.
They are congruent because since angle WVS is congruent to angle S and the angle S is congruent to angle R, we can find the two sides are congruent by the theorem 4.
Comparative.
Sorry, can you repeat? Since now in the triangle WVS, since now WV is congruent with WS, so
yes. Then we can say that angle S is congruent to angle R, and we're going to use we're going to use theorem 4 to find the two angles. They are congruent.
But teacher, they are asking about RUV is isosceles, so they need only the side and the base angles. The base angles which are R and V.
He asked me
And
about
there is no enough.
Teacher, angle WVS is congruent to angle S. And
yes, WVS is congruent with an angle S.
yes, angle S is congruent to angle R.
Before that, and now angle WVS is congruent with an angle S, and angle R is congruent with an angle WVS.
Yes.
Yes?
Yes.
Yes,
So,
teacher.
can I say now that angle R is congruent with an angle S?
Yes, teacher.
Yes.
Yes. Yes.
And since the base angles R and S are congruent, so I can conclude that TR is congruent with TS.
Yes.
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 Yes, teacher.
Look here.
Teacher, you are asking about got it 1A?
Yes, I'm in 1A.
1A?
Yes, I'm A. But here you have, look, you have two questions. Wait. The first one is here, and the second one is here.
So they are congruent.
Oh, I thought teacher you are in 1B.
No, I'm in A also. Yeah, I'm still in A.
Oh,
So, in this one here, angle V is congruent with an angle S because these two sides are congruent. And also, angle R is congruent with an angle V.
Teacher, are you writing?
No, I'm just talking.
Oh, okay.
I'm gonna right now. So the second one here, the answer is yes. Since the angle WVS is congruent with an angle S, WVS, this angle, is congruent with this angle. That's I proved in the previous term. WVS is congruent with an angle S. And also, the angle R is congruent with an angle WVS. Angle, look at this one here. This one, the orange one, R, is congruent to V. It's given. The first one, angle WVS, is congruent with an angle S. That's I proved in the first term. The second one, he gave me from the question that angle R, this one, okay, angle R is congruent with an angle V. It's given from the question. Did you remember the transitive property of congruence?
Yes.
If I told you
Yes.
that A is equal to B and B is equal to C, so that's mean A is equal to C?
Yes.
Here
Yes.
I have to use it. Since angle WVS is congruent with an angle S, and also angle WVS is congruent with an angle R, so I can say now that angle S is congruent with an angle R because of the transitive property.
Miss teacher,
Since now the angles are congruent, can I say now that the TR, line segment TR, is congruent with TS?
yes.
So yes, I
Yes,
say now
teacher.
that the line segment TS is congruent with TR because of the theorem 4-4. Because in theorem 4-4, we say that if we have two angles are congruent, so their opposite side will be congruent too. Is it clear?
Yes.
Yes, teacher.
Wait,
Yes.
Yes, miss. Yes.
Okay. Did you write?
yes, I wrote.
Miss, one
Take
minute.
1
I'm
minute.
writing the last one.
I want to clear here. Now, let's talk about B now. In B, can you conclude that the triangle R, here is it right? It was here, I think. RUV, this triangle. Can I say it is isosceles triangle?
No. I say teacher, no.
Because there is no enough information.
No, teacher.
Thank you. There's no, so I cannot say it is isosceles because there's no
Enough information.
enough information. Thank you.
Teacher,
Yes.
theorem 4-3 and theorem 4-4, they are converse, and you mean that in the theorem of 4-3, they are saying that if two sides are equal, so the angles are equal. But of theorem 4-4, it says that if the two angles are theorem, so the two sides are theorem, so they are opposite of each other.
Yes, أيوة, exactly. They are opposite each other.
Okay.
Now, here now, we are going to talk about another theorem. In this theorem here, I want all of you to leave your pencil or your pen and focus with me. In this one here, he told me that if you have this triangle, there is A, so if in this triangle here we have A, here we have B, and here we have C. Now, if a line bisects the vertex angle of the isosceles, I said before that here is, we name this one with a vertex and vertex angle, and this one we name it with a base angle, and this one also we name it with a base angle. Now, in this theorem here, he told me that if there's a line bisects the vertex angle of an isosceles triangle. So, which type of triangle I'm talking about? I'm talking about isosceles. Isosceles, that means these two legs are congruent. In this isosceles triangle, if you have a line that comes from the vertex cut the base. I have this line, it starts from the vertex, cut the base. If this line bisects the vertex angle, what I mean by the side or the bisects or the line, sorry, bisects the angle? What does it mean? I told you before, if you have an angle and there's a line that bisects it, what will happen with these two, with this angle?
It will be equal.
It will be equal. This bisects is cut the angles into two equal half. So that's mean this bisector now, it makes this angle equal with this angle. Okay? Here I have a isosceles triangle. For the isosceles triangle, all of us know that this side is congruent with this side. I bring now a line, and this line, it's bisect the vertex angle. It cuts the vertex angle. He told me now, if I have now isosceles triangle, and there's a line, cut the vertex angle, so this line will be perpendicular on the base. So if AC is congruent with BC, this one, which is an isosceles, if AC is congruent with BC and ACD, this one, is congruent with BCD, with this one, if they are congruent and if the angles in the vertex are congruent and if the two legs are congruent, so I can say now CD is perpendicular on AB, and since it is perpendicular and it is a bisects, it must be perpendicular. So because of that, I can say now it cuts also the side. As I told you before, the bisector, if it is come on the angle, it cuts the angle into two equal halves. And if it comes on a side, it cuts the side into two equal halves. Yes. So that's mean AD is equal to BD. And I can say now AD is congruent with BD. I will tell you, or I will repeat it, but in another way now. Where's the... If I have now this triangle, and this one, it is congruent. That's mean it is an isosceles. And there's a line. I bring this line, and this line now, it's bisect the angle. If it is bisect the angle, I told you before, if there's a line that's bisect the angle, so that's make this angle equal with this angle. If this line now, it comes in isosceles triangle and bisects the angle, so it will be perpendicular on the base, and also it cuts this two sides into two equal sides. That's mean if I have this triangle now, and this one is 4, and this one is 6, and this one is 10, and there's a bisector comes here, it cuts the angles. Okay, is here 5 and here 5?
Yes.
The others?
Teacher, I
Yes,
don't understand the
teacher.
question.
Here you have this triangle. The length of the base is 10. And there's a bisector. It cuts the angle into 2 equal halves. Does it make, or does it make, yes, the side, or cut the side into 2 equal halves? So it will be 5 here and 5 here.
Ah, yes.
Yes.
Judy, where's Judy? Judy? Where's Ranim?
Yes, teacher.
Does this bisector cut the line into 2 equal halves?
Yes.
Sarah? All of us say yes?
Yeah, teacher.
Yes,
Teacher,
Sarah.
you said that.
I say yes.
I said yes.
Which
Sarah?
bicep, teacher?
Me too, teacher. I say yes.
I said
Teacher, which bicep?
Here, I'm talking about this triangle, the purple one. I'm talking about this bisector now.
yes, it cuts equal.
Yes, teacher.
I'm asking you now. I told you if a line bisects the vertex angle of an isosceles triangle. Is this one
No, teacher.
an isosceles?
No, no.
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 No, teacher.
So,
There's not cut into
so
two parts.
it cannot happen.
They are not equilateral.
It must be isosceles, not equilateral. Isosceles. It must be isosceles.
Teacher,
Yes.
but the definition of a bisector, it's perpendicular to the line, so it will give you 2 equal angles and 2
No,
sides.
it's not perpendicular because the triangle is not isosceles. I told you it has the line. It must bisect the vertex angle of an isosceles triangle.
Teacher, it's
must
also
be
not
isosceles.
equilateral.
Yes, my equilateral. It's a the isosceles is one, or it could be an. لا wait, the equilateral it could be a isosceles.
Teacher, this triangle that you made, that the one is not equilateral because the sides are not the same. They're not
yeah.
equal.
لا she told he in this the purple or the pink one.
No, the
Not
purple.
purple.
Yes, it's not isosceles.
And it's not equilateral either because
And also
every
yes,
side is not equal.
yes, and it's not also equilateral. Fine. Another thing.
Miss, they must say that this line bisector to this side in a perpendicular. They said CD bisects side AB or is perpendicular. So it will give you 2 equal sides, AD and DB.
Yes, if it is isosceles triangle and these bisects cut the vertex angle. So, another question. Yes.
When we were solving in the previous lessons, they gave us a shape. It consists of triangles. So these triangles were isosceles.
Send me the question on WhatsApp, please. I forget it.
Okay, Miss.
Okay. Now look at this triangle here. Here is 6. Here is 6. This one, it comes from here to here. Now look at this one here. It is an isosceles triangle, is it right?
Which one, teacher? The purple
The
or
purple
the
one, the
pink?
purple one,
teacher.
yes. It is
Yes,
isosceles,
miss.
yes?
Yes.
Okay.
Yes.
Yes.
Now
because
look
it
at
has
the
two equal
bisector.
sides.
Yes.
Now look at the bisector. Does it cut this one into two equal halves?
No.
No.
Does it cut this one here? This one I'm talking about. Wait, please. I'm talking about this one here, the pink one. Does it cut
Yes.
it into two equal halves?
Yes. No.
Yes.
No.
Yes.
No.
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 Why
What?
no?
Yes.
No,
Why
teacher,
teacher,
because
no?
the line down is not 6, so it's not going to be the same.
Yeah.
No. No, it is 6.
It's a
Here
no.
it's linked to 6, and here it is 6 also.
Yes, I mean the bisector. If we flipped it and it's the same as the bisector going to cut 6, it's going to be n3. But then, like the line down there is not going to be equal because there is no number for it. So we do not know if it's going to be the same.
But teacher, they said to you that this is a bisector, so we can conclude that we
Yes,
cut it
miss.
to halves.
Here there's a line. Okay, I mean now the purple line. The purple line, is it cut this one into two equal halves?
Yes, teacher.
Yeah, teacher, it
Yes,
can be.
miss.
Yes.
But
Yes.
is this
Teacher,
line?
no.
Is this
Yeah,
line? Wait. Is this line comes from vertex angle?
No, teacher, it doesn't.
No.
No.
It doesn't.
So it's not
But
work.
teacher, it cuts and it cuts an isosceles
It's cut it.
Teacher,
triangle.
it can be work when you flip.
It's cut it. Yes. This one it comes from
Teacher,
here and here. Right? It's cut it, but it didn't cut it into two equal halves. And in the third one here, it didn't cut it into two equal halves. So here, if this theorem work, you have to know that if the line must bisect the vertex angle, not the base angle, the vertex angle only. Okay, and the triangle must be isosceles. If the triangle is isosceles and the line comes from the vertex angle, that's mean this bisect is perpendicular on the base and cut the base into two equal halves.
Miss, I didn't understand it so much.
Me too, miss.
Okay.
Me too.
If you have here this triangle, here, he told me now, if you have this triangle and this triangle have two congruent sides, that's mean it is isosceles. If there's a line comes from the vertex angle, in an isosceles. So there's a line. It comes from the vertex angle in an isosceles triangle. That's mean if these two things happened, that the line, it cut or it bisect the angle and it is inside a isosceles triangle, this line will be perpendicular on the base and cut the base into two equal halves. Now,
Teacher, the theorem, I understand it, but the example which is, I know, teacher, the definition of a bisector, it cuts two sides if it is perpendicular to the line, and the question told me, so it will Immediately cut the line into 2 halves, or the base into 2 halves.
Okay. So what's the problem with you? No, I just
Yes,
here, this is not examples, but here I told you that it must come from the vertex, not from the base angle. Yeah, you have this triangle, okay? But if this, wait, if this line comes from a base angle, okay? If it comes from the base angle, from here, okay?
okay.
Okay,
Yes.
it's coming from the base. It's not coming from the vertex. So I cannot say that this line is cut these two lines into 2 equal halves.
Yes, yes. Now I understood. I was confused. I forgot to do the base angle. Now I remember.
Okay. Now, after that, I want you now to I want now to prove this theorem, and this proof is not written in your book because, as you see here, that you wrote you will prove theorem 4.5 in exercise 26. So let's prove now this theorem. If we have this triangle now, which is A, B, and C, and there's a line that cut the angle, the vertex angle, into 2 equal halves in a isosceles triangle. There, girls, I think that we cannot continue this one because the period will finish after less than 1 minute. So tomorrow we will solve, I will prove this theorem and we continue our lesson.
Okay.